Hello, today we start new chapter, Electrostatic Field, and these are the subtopic of this chapter. First topic is Coulomb's law and field intensity. Electric field due to continuous charge distribution. There are the three types of the charge distribution: line charge, surface charge, and volume charge distribution. Next, electric flux density. Next, divergence and divergence theorem. Gauss law, which is nothing but the Maxwell equation, and last one is application of Gauss law. So here the chapter itself, it state the field is electrostatic field. So let us start with this chapter with the concept of what do you mean by electrostatic. Okay, so as we know that there are the two types of field, electric field and magnetic field. Okay, so as we know that there are the two types of field. First field is known as electric field and second field is known as the magnetic field. So if I have to combine these two fields, so it is known as electromagnetic field. Okay, so electromagnetic field actually is a combined word of electric and magnetic field. Now there are the two types of electric field. Similarly, there are the two types of magnetic field also. Okay, which type of the two types of the electric field? So first is known as static electric field and second is known as dynamic, or you can say that time varying electric field. Okay, similarly the magnetic field also, first is static magnetic field and second type of magnetic field is time varying magnetic field. Okay, now the question is, what do you mean by the static electric field? Static electric field means the electric field which does not change with respect to time. What is time varying electric field? That means the electric field is changed with respect to time. Okay, so actually in a practical case we use time varying electric and time varying magnetic field. Whatever the electromagnetic wave propagate in any type of medium, or you can say that in the air or space, if electromagnetic wave is propagate in any medium, so those electromagnetic field are always time varying electromagnetic field. Okay, so there are the various sources are available for static time varying electric field as well as static and time varying magnetic field. Okay, so as we know that which one is the source of static electric field? So charge, okay, fixed charge is a source of static electric field. Which one is the source of static magnetic field? DC current is a source of static magnetic field. Okay, so there are the various sources are available here. Clear? So in this chapter we have to discuss about the static electric field. Okay, and in next chapter we will discuss about the static magnetic field, and after that we have to combine these two, time varying electric field and time varying magnetic field. Okay, so first, what do you mean by the static? Static means it is time independent. That means if you are to take a partial derivative of electric field, so answer is 0. Okay, because it is time independent. But what about the time varying electric field? If you do the partial derivative with respect to time t, so it is not equal to 0. Similarly for magnetic field, okay, so generally the magnetic field is represented using H. Okay, we will discuss about it. So for static magnetic field it is 0. For time varying magnetic field it is not equal to 0, all those things. Okay, one more thing that I want to note, that time varying magnetic field generate electric field and time varying electric field generate a magnetic field. Okay, we will discuss all those things in upcoming chapter. Okay, so it is just basic concept regarding static and time varying electric and magnetic field. So this chapter is static electric field. That means this one, partial derivative of electric field with respect to time is 0. That means electric field is independent of time. Okay, so it is known as electrostatic. Okay, so it is known as electrostatic field. So our chapter is electrostatic field. Okay, electrostatic means it is time independent field. Okay, so which are the source of electric field? So as we know that just I have to take a simple concept of capacitor. Okay, as a electronics engineer we know that what is the capacitor. So capacitor is nothing but there are the two parallel plate which is separated by some distance d. Okay, one plate has a positive charge and another plate has an equal amount of negative charge. Okay, so now here field is generated. So the field is generated from positive to the negative side. Okay, between two plate it is a dielectric medium and electric field E is generated from positive plate to the negative plate. Okay, so from the simple concept, okay, so it's a capacitor. So from the simple concept of the capacitor we know that when the electric field is generated due to the fixed charge. See here, this charge is charge on the positive plate and as well as the charge on the negative plate. These two charge are fixed charge, they are not movable charge. Okay, so that is why it is known as static charge. They are not a movable charge, it's a fixed charge. Clear? Okay, and it's not a, here we assume it's not a time varying charge. Okay, it's a fixed charge. So fixed charge always generate which field? Fixed charge generate the electric field. So if charge is fixed charge, so it generate a electric field. Okay, so in the case of capacitor there are the two types of the charge that present, positive and negative charge. And if you notice, what is the direction of electric field? The electric field direction is from positive charge to the negative charge. Okay, so here I have considered a simple case. So suppose I have to draw one charge. Okay, I have to consider a single charge. See here, I cannot use the word of electron, proton. Okay, I have to consider a charge. Positive charge, that means you have to consider a proton. Negative charge means you can consider as a electron. Okay, so I have to consider one charge and the charge is positive charge. Okay, so this one is my charge and charge is a positive charge. Okay, so this is a plus q. I can write in this way, is a plus q charge. Clear? Now my second charge is negative charge. Okay, so here it is negative charge which is minus q. Okay, so here two charge are present, plus q charge and minus q charge are present. Okay, now first I consider only plus q charge. Okay, so now this plus q charge generate a electric field. Okay, so now I have to draw how electric field is generated from this positive charge. Okay, so now I have to draw the electric field line. Okay, so here the electric field is generated in this way. Okay, so actually these are the line of electric field. Clear? So this is the electric field. Okay, so from this figure we can say that the field intensity is decreased as the distance is increased. Okay, so actually the field is generated in this way. You can consider a case of sun. Okay, so sun radiates its energy in all the directions. Okay, similarly you can consider a case of one bulb, electric bulb. So electric bulb generate a light in all the direction. Similarly we can consider it's a one type of sphere. Charge is a one type of the sphere. So this charge produce their electric field in all the directions. Okay, so this charge produce the electric field in all the directions. Clear? So this one is a plus charge, positive charge, so it generate electric field in the outward direction. What about this negative charge? So this negative charge also generate electric field but in the reverse direction. Okay, so this negative charge actually it's a generating field. Okay, but the direction is just reverse. Okay, no space is available, so I cannot draw here. So this one is the field of negative charge. Clear? Okay, so direction of electric field due to positive charge is outward, direction of electric field due to the negative charge is inward. But what is the condition? The condition is this two charge must be a fixed charge. Fixed charge means steady charge, it's not a movable charge. Okay, listen, if charge is movable, so it generates a magnetic field, because what is the source of magnetic field? The source of magnetic field is current. Okay, so as we know that if the charge is movable charge, if all the charge move in one direction, so it forms a current. So that is why it generates a magnetic field. But here we discuss the static electric field. Okay, so these two charge are fixed charge, so they generate a electric field in all the direction. If charge is positive, it generates in the outward direction. If charge is negative, it generates in the reverse direction, in the inward direction. Okay, so it's a simple concept of electrostatic field. Okay, so in this chapter we have to consider this type of charge. Okay, so I have to draw only two charge. One is positive charge and second is negative charge. There are so many charges are present here. Okay, so now there are the three cases. First, the charge is present on the line. Second, the charge is present on the surface, and third, the charge is present on the cube. Okay, so see here, suppose just I want to touch this topic. Okay, see here, the first case, if the charge is present on the line. Okay, so I have to draw one simple line. Okay, it's a one simple line, it's a single, okay, it's a one simple conductor or aluminum wire, you can aluminum or copper wire. Okay, so now lots of charge are present on this line. So now tell me how much amount of charge is present. We cannot count the number of charges. Okay, there are lots of infinity charge are present on this conductor. Suppose infinity positive or infinity negative charge are present. Okay, let us consider the infinity positive charge are present on the conductor, on this line. Okay, so all the charge are fixed charge, so all the charge generate a electric field. Okay, clear? Similarly, if I have to consider a plane or surface. Okay, so suppose this is on a simple surface, simple plane. Okay, so now similarly, same way, there are lots of or infinity charge are present on the surface, and all the charge are fixed charge. Okay, infinity charge are present on the surface, and all those charge generate a electric flux. Okay, and last case is volume. Okay, so you can consider one cube. Okay, has a volume. We can consider one simple cube. Okay, so here also infinity amount of positive or infinity amount of negative charge is present inside the cube or on the surface of the cube. Okay, and all the charge generate a electric field. Okay, so here I have to draw only one charge. So only one charge is responsible for electric field. So similarly, here is only one negative charge. It is also it is also responsible to generate a electric field. Okay, so actually we will discuss all the three case: line charge, surface charge, and volume charge in our next topic, electric field due to the continuous charge distribution. Okay, but I will just give the idea regarding the charge distribution. Here I have to consider a single charge, but on the line, on surface, and on the volume there are infinite number of charge are present, and all the charge generate a electric field. Clear? Okay, so now let us discuss the first question, our first topic, which is Coulomb's law and electric field intensity. Okay, so as we know that what is the Coulomb's law, so I have to consider these two figure. So we know that the Coulomb's law is nothing but actually it is a force. Okay, force between two charge. Okay, if two charge are different magnitude, okay, this one is plus q and minus q, so there is a attractive force between these two charge. If the two charge have a same magnitude, so there are the repulsive force between the two charges. Okay, so this force is depend on what? So this force is depend on the magnitude of charge, and it also depend on the distance between these two charge, and it also depend on the types of medium. Okay, so now let us start with our first topic. Our first topic is Coulomb's law. Okay, so actually it's very easy. So in Coulomb's law, what we assume, in Coulomb's law we have to consider there are the two charges are present. Which are the two charge? Okay, I have to again draw that figure. Okay, so I have to consider this one is plus q1 charge, next charge is plus q2 charge. or you can consider minus q2 also, okay, but it's a plus q2 charge. Okay, so plus q1 charge and plus q2 charge, both the charge are present, and here both the charge we consider is a static charge or fixed charge. Okay, so both the charge generate a electric field in all the directions. Okay, so this both charge generate a electric field in all the directions. So what this line is indicate? This line is indicate the direction of electric field. Okay, then we discuss about what is electric field intensity exactly. Okay, so charge is positive charge, so it generates electric field in the outward direction. This charge is also a positive charge. Okay, so it can also generate a electric field in the outward direction. You can consider the negative charge also, but here we consider the both charge are same polarity, both charge are positive charge, so they can generate electric field in outward direction. Okay, clear? So now which force occur between these two charge? Of course, repulsive force is occur between these two charge, because this charge is plus q1 charge, okay, and this charge is plus q2 charge. Both charge is positive charge, so there is a repulsive force between these two charge. Okay, so force is depend on what? So here force F is proportional to the magnitude of charge. If the value of charge q1 and q2 very large magnitude, very okay, so the force value is very high. So force is depend on q1 and q2. Okay, and suppose we can say that there is a separation between these two charge, okay, which is known as R. Okay, so force is inversely proportional to the square of the distance. Okay, so see here, if these two charge are separated very large distance, okay, so now there is no force between two charges, there is no repulsive or there is no attractive force between these two charges, because suppose the plus q1 charge is here and plus q2 charge is here, there is a very large separation between two charges, so there is no force between two charges. Okay, similarly we consider two person. Suppose here one person is standing, okay, the second person is standing very far away, so actually there is no any feeling between these two person. Okay, clear? So same way, if there is a very much separation between two persons, so there is no force. Similarly, there is actually there is a large separation between two charge, okay, so no force between two charges. So that is why if the distance between two charge is increased, so force is decreased. Okay, and it is inversely proportional to the square of the distance. It is scientifically proved. Okay, now the question is why it is inversely proportional to the square, not only inversely proportional to the distance, because it is scientifically proved that the force between two charges is inversely proportional to the square of the distance between two. Okay, so if I have to combine these two, so I can write this equation in this way: F is equals to remove this proportionality constant, so this K is a proportionality constant, Q1 Q2 upon R square. Okay, now here what is K? So as we know that K is equals to 1 upon 4 pi. Okay, K is nothing but K is equals to 1 upon 4 pi. Okay, again it is scientifically proved K is equals to 1 upon 4 pi. So force F is equals to Q1 Q2 upon 4 pi R square. Okay, so this one is the equation of force between two charge. Okay, so force between two charge is directly proportional to the magnitude of the charge, but it is inversely proportional to the square of the distance. Now, as we know that force is a vector quantity. Okay, in the first chapter we have to differentiate what do you mean by the vector and what do you mean by the scalar quantity. So force is a vector quantity. So now I have to write the equation of force on first charge due to the field of second charge. Okay, so first of all I will write F12. So what F12 is indicate? F12 is force on first charge due to electric field of second charge. Okay, similarly you can write F21 also. Okay, but F12 means force on first charge due to the electric field of second charge. So this F12. So F12 is equals to Q1 q2 upon 4 pi r square. But it is not only r, it is r12. R12 is indicate the distance between first and second charge, so it is r12. So again, what is F12? Force on first charge due to the electric field of second charge. Okay, so this F12. Okay, so here we have to consider which field. We consider the field of second charge. Okay, and we consider how much force is exerted on the first charge due to the second charge. Okay, so in this case, this one is my vector. Vector is from 1 to 2. Okay, here it is my charge q1 and here it is my charge plus q2. Here we consider the field of second charge and we have to find out the force on the first charge. Okay, so I have to draw this vector, the vector from 2 to 1. Okay, so here the vector is from 2 to 1. Okay, so you can write in this also. So this is a 1. Okay, it is a to 1. Okay, a12 from 2 to 1. So this a12 vector. Okay, so this vector is known as which vector? a12. Okay, so this one is the equation of force on first charge due to the electric field of second charge. Okay, so this one is the magnitude of the force, and what it indicates? It indicates this one is the unit vector of the force. And what is the purpose of the unit vector? As we know that unit vector, it only gives the direction, it never alter its magnitude, it only gives the direction. So force is applied on which direction? Force is applied from point 2 to point 1. So it is a12. Okay, but what is the definition of unit vector? The definition of unit vector is, it is nothing but vector upon its magnitude. Okay, so if I have to write this one, if I have to put this value, so what is F12? F12 is q1 q2 upon 4 pi r12 cube, this r12 cube into r12 vector. Clear? But this one is a standard equation of the force. Okay, so this quantity only indicates its magnitude, and this one is okay, this one is indicate its direction only. Okay, so it is a force on first charge due to the electric field of second charge. Similarly, F21 vector. F21 means force on second charge due to the electric field of first charge. Okay, so F21 is equals to q1 q2 upon 4 pi r21 square, and now the vector is from 1 to 2. Okay, so here it is 2 to 1. Clear? Okay, so this one is the equation of force on second charge due to the electric field of first charge. Okay, so if you compare these two, two equation, so what you concluded? We concluded that okay, which quantity is differ? So this one remains same. Okay, the magnitude remains same. So which one is changed? Only and only direction is changed. Here it is a21 and here it is a12. Okay, so just is a negative. Okay, so from this two equation we can say that here F21 is equals to minus F12. Okay, so this one is our final conclusion regarding the force. Okay, so actually it is known as Coulomb's law. So Coulomb's law is nothing but it's a force law between two charges. Okay, so it's a very easy Coulomb's law. So the final statement is the force. So what Coulomb's law state that? Coulomb's law state that the force between two charges is directly proportional to the magnitude of charge, but it is inversely proportional to the square of the distance between two charges. Okay, now so here we complete our first topic, which is Coulomb's law. Now we discuss about what do you mean by the field intensity. Okay, so now based on the force equation, now we have to find out, or we'll get the concept regarding the field intensity. Okay, so now my next definition is field intensity. Which field? Electric field. Okay, so this field intensity. So to understand the field intensity concept, what I have to consider? I have to consider that this red charge is very big and this blue charge is very small. Okay, so here to understand the concept regarding the field intensity, I have to consider that there is one big charge is present here, okay, which is plus q1. Okay, so plus q1 charge is present here, and now very small charge is present, which is plus or minus, you can say any charge. Okay, suppose plus q2 charge is present anywhere on these pages. Okay, now I have to just draw the field direction. Okay, so this arrow, this vector shows electric field direction. Okay, or it is also indicate it's a intensity, because as the distance is increased, okay, if you notice, if the distance is increased, the length of this vector is decreased at all. Okay, so now you can consider plus q2 point in any place. Okay, now suppose I have to consider my point, my second charge is here. Okay, it is plus q2 charge, it's a very small charge, plus q2 charge. So plus q2 charge is present here. Which charge is very bigger? Plus q1 charge is very bigger, plus q2 charge is very small. Both the charge are positive. So which force is exerted between the two charge? Repulsive force. Okay, but now the question is, which charge contains some moment? Okay, if there is a repulsive force between two charge, okay, which charge contains the displacement? Of course, plus q2 charge has displacement, because the plus q1 charge is very heavy charge and plus q2 charge is very light charge. Okay, so there is a displacement of plus q2 charge. So if I have to put plus q2 charge here, so there is a strong repulsive force between these two charge, and there is a displacement of plus q2 charge. Okay, suppose I have to put plus q2 charge here. Now what happened? Again there is a repulsive force between these two charge, but this force, okay, the amount of force is less compared to the first case. Suppose I have to put plus q2 charge here, then what happened? The force between two charge, okay, the force between these two charge is less compared to the first and second case. Okay, and lastly, suppose I have to put plus q2 charge at the out of the field of the first charge. So there is no force between two charge, because the plus q2 charge is outside of the field of the plus q1 charge. Okay, so because as we know that the force is inversely proportional to the square of the distance, here the distance is minimum, so force is maximum, and in this case, in the last case, the distance is maximum, so the force is minimum. Okay, or so here I have to consider total 4 points, first point, second, third and last fourth point. Okay, so if you notice at the first point, the field is very strong. The electric field due to the plus q1 charge is very strong. At the second point, the field due to the plus q1 is strong, but it is weak compared to the first point. At the third point, the field is weak as compared to first and second point, and at the fourth point there is no field. So the electric field due to the plus q1 charge is 0 at the fourth point. Okay, that means what it indicates? It indicates strength. It indicates the strength. Okay, so at the first point the field strength is maximum, at the second point it is decreased, at the third point it is again decreased, and at the fourth point it is very less, or you can say that ultimately it is 0. Ideally it is 0, but practically it is very less. So electric field strength is very less at the fourth point. Okay, so we can say that the electric field strength is maximum at the nearest point of the charge. Electric field strength is maximum. Okay, you can consider the case of halogen bulb or a simple electrical bulb. Okay, so at the nearest point of electrical bulb, the light is maximum, the intensity of light is maximum. But if you go very far away from the bulb, so now there is no light is present. Okay, so there is no intensity of the light. Okay, so actually this concept is known as field intensity. So at the first point the field intensity is maximum, at the second point it is minimum, at the third point it is again minimum, and at the fourth point the field intensity is 0. So what do you mean by the field intensity? Field intensity means strength. It is ultimately, it is known as the field strength at each and every point. It is known as the field intensity. Okay, so the field intensity is maximum at the nearest point of the charge, and the field intensity is minimum at the furthest point of the charge. Okay, so now my question is, suppose I have to draw one circle with the same radius surrounding the charge. Okay, I have to draw one circle surrounding the charge has the same radius. So at each and every point the field intensity is same. Okay, at each and every point on this circle the field intensity is same. Okay, but suppose if I have to draw another circle. Okay, so at this circle the field intensity is less compared to the first case. Clear? But the field intensity is same around the second circle, but the field intensity around the second circle is less as compared to the first circle. Okay, so it is known as electric field intensity. Okay, so it's just a simple idea regarding the field intensity, or you can say that it is field strength. Okay, but as per the definition we know that what is a force equation? The force F is equals to Q1 Q2 upon 4 pi r square. Okay, I have to consider only its magnitude. Okay, you can consider the vector also. Okay, so now as per the definition, what is electric field intensity? Electric field intensity means force per charge. So force per which charge? Q1 apply force on Q2 charge. Q2. Okay, so this Q1 upon 4 pi r square. Okay, so force per unit charge, it is known as electric field intensity. So force per charge, it is known as electric field intensity. E is equals to Q1 upon 4 pi r square. Okay, so this electric field due to which charge? Charge Q1. So it is known as E1. So E1 is equals to Q1 upon 4 pi r square. Okay, and as we know that electric field intensity is also a vector quantity. Okay, so E1 vector is equals to Q1 upon 4 pi r square to multiply it with AR unit vector. And here what is AR unit vector? AR unit vector is R vector upon its mode. Now what is R? R is the distance between charge Q1 to my desired point. It is a distance. Okay, suppose I have to consider this point 2. So this one is my distance R with respect to charge Q1. So it is a simple definition of electric field intensity. Electric field intensity means force per unit charge. So what is the unit of E? Unit of E is force per charge, that means Newton per Coulomb. Okay, and another unit is volt per meter. Okay, we will discuss on that. Clear? So this Newton per Coulomb. So this is known as electric field intensity. So electric field intensity is nothing but is a strength of your field. Okay, see here, the charge is known as source. Okay, and the field which is produced by the source is known as cause. Okay, so it's a source and cause. Okay, you can consider just a case of a sun or a simple electric bulb which can produce a light in all the directions. Okay, so at the nearest point of the bulb the field intensity is maximum, the light intensity is maximum, and if you go away from that electric bulb, okay, so light intensity is decreased. Okay, so you have to apply the same concept here. Clear? So here we have to finish the first topic. The first topic is Coulomb's law and electric field intensity. Okay, so in next lecture we will discuss about electric field due to continuous charge distribution, line, surface and volume charge, and we will touch this topic, what is electric flux density, divergence and divergence theorem. Thank you.